Hi, my name is Williams, and today we'll be talking about data structures and algorithms, and precisely we'll be talking about arrays and hash map. Now, when we need to iterate through an element, arrays are best for fast lookups, also best for push and pop. Now, I will explain. Let's take this variable for example called nums. Const nums. Nums is just a list of numbers. So these numbers, let's say we want to look up. Also, we know that elements in arrays are ordered. They are ordered from 0 index all the way up 3, 4. So let's say we want to look up an element in this array. Let's, for instance, want to look up the element of 3. So let's just console.log nums at index of 1. So if we console this now, if we run this in our console, we know we will get what? The value of what? 3. Because 3 in this case is at index of what? 1. And for doing this, so we talk about fast lookups. They are best for fast lookups. So for doing this, for looking up this value 3, it takes what? Big O of 1 time complexity, which in this case is a what? A constant what? Time. It's a constant time. So why is it a constant time? If we look at this array very carefully, we know that we are not actually shifting any indexes. We are just what? Looking up a value. So we are not shifting indices and we are not performing a linear search in this array. We are just what? Looking a particular element and taking the value based on the index that the element is sitting on. Again, we also be talking about fast what? Push or pop. Arrays are good for fast push or pop. Now when we talk about push in JavaScript, it means adding elements to the end of the array. We talk about push, it means adding an element to the end of the array. In this case, let's say we want to add the value of 8 inside of this array. So we have to say nums dot push. Let's say we are pushing the element of what? 8 in this array. So if we push these elements in this array, the resulting array that we will receive will be 1, 3, 7, 4, 5, and 8. In this case, the indices are 0, 1, 2, 3, 4, 5. In this case, we know that the index of 8 that we just push into this array, which is this resulting array, is what? Index 5. So if you look carefully, you see that we are not what? We are not shifting any index in this array. We are just what? Adding to it. We are adding to it, and the time complexity it takes for this operation, for this item or this element A to be added to this array is big O of 1, which is also a constant time. O of 1, which is also what? A constant time. Now let's talk about pop. Pop in an array means what? We are removing what? Element at the end of the array. Removing what? Element at the end of the array. So in this case, let's say we want to pop these 8 out of this array. So if we pop it, nums.pop, we are basically removing this last element from this array. So the resulting array we are going to be getting will be what? 1, 3, 7, 4, and 5, which also have an index of 0, 1, 2, 3, and 4. In this case, this 8 that will just pop out you see very carefully that we are not shifting any index here. We are just removing this 8 and returning the resulting array, which in this case is 1, 3, 7, 4, and 5. So we know that the time complexity it takes for this operation is big O of 1, which is also the same as for the push, which in this case is a what? A constant time. A constant time. The Y for insert and delete, it's very slow. It's pretty slow in array. So let's take an example. Let's take an example. Let's say, for instance, we want to insert the value of 2 at an index of 1. We want to insert 2 at index 1. Let's say we want to insert 2 at index of 1. The value at index of 1 is 3. So basically, we want to take this 2 and insert it to where this 3 is. Then shift the indices. So we take our 1. So we know 3 is no longer here. 2 is now at this index. 3 is here. 7, 4, and 5. In this case, the new index will now be 0, 1, 2, 3, 4, 5. You see, we've managed to shift the indices by 1. In this case, 2 is now at index 1, 3 is now at index 2, 7, which was at index 2 initially, is now at index 3, 4, which was at index 3 initially, is now at index 4, while 5, which was at index 4 initially, is now at index 5. So basically, we are performing a linear operation on this array. That is, the time complexity it takes for us to insert elements to this array is what? Big O of n, which in this case is a linear time? A linear time. So if you look carefully, you see that we shifted indices. We have to touch every element in this array. Touch every element. Shift the indices of every element in this array. We insert 1, we shift 3, we shift 7, we shifted 4, we shifted 5. So that is for insert. Also, let's talk about delete. This I say is pretty slow. Insert is slow. Slow in an array. So let's talk about delete. In this case, if we want to delete an element at index of 2, let's say we are deleting an element at index of 2, which is this. We want to delete 7. So if we are deleting 7 from this array, so we know the resulting array we'll be getting will be what? 1, 3, we've removed 7, so we're not getting 7 again. 4 and 5. So in this case, the indices is now 0, 1, 2, 3. So we see that 0, 1, 4, which was at index of 3 before, is now at index 2. 5, which was at index of 4 before, is now at what? Index 3. So we've managed to shift the indices backward. That is for delete. And this operation takes what? Big O of n, which is what? A linear time, because we are actually touching every element in the array. We are shifting the indices, and it takes O of n time complexity to perform this operation. Again, in array, the elements are ordered. Elements in array are ordered. So you see that we are starting from index of 0, 1, 2, 3, 4, and so on and so forth. So if there is one point you take from this lesson is that arrays are good for fast lookups. These are the pros of arrays. One, they are good for fast lookups. Two, they are good for fast push or pop. Then three, they are also ordered. They are ordered. These are the pros. Then for the cons, we have what? They are slow for insert. They are slow for insert. They are also what? They are also slow for delete. So basically, you understand why they are slow for insert, and also why they are slow for delete, because you actually have to what? Shift the indices, which takes BigO of n, which is a linear time, slow for delete. If there's anything you have to take, just note this down. Arrays are fast for cubs, fast for push or pop, they are ordered, while for the cons, they are slow for insert, they are also slow for delete. So we've come to the end of this lesson. By the next lesson, we'll be treating some questions involving arrays. So if you haven't subscribed to this channel, I want you to subscribe, like this video, share it, and we'll see you in the next video. Thanks for watching. Bye.